In this tutorial we will discuss nuclear magnetic resonance NMR. Let's start with introduction. Nuclear magnetic resonance NMR takes advantage of the magnetic properties of the protons and neutrons in nucleus. The magnetic fields of the protons and neutrons add up to give the nucleus a magnetic field, and sometimes the magnetic fields of the protons and neutrons add up so that the nucleus has no magnetic field. Any nucleus that has a magnetic field can be detected with NMR. NMR is operated by applying a magnetic field to certain nuclei and then measures the amount of energy required to put various nuclei in resonance. This technique allows the molecular structure of a material to be analyzed by observing and measuring the interaction of nuclear spins when placed in a powerful magnetic field. It is a powerful medical imaging technique that is used to image the anatomy and the physiological processes of a human body. Principle. The principle behind NMR is that many nuclei have spin and all nuclei are electrically charged. The major nuclei of atoms possess magnetic moments and angular momentum, and when external magnetic field is applied to them, they arrange themselves in the direction of the magnetic field. When a molecule is placed in a magnetic field, its electrons are caused to circulate and thus, they produce a secondary magnetic field that is induced magnetic field. The rotation of electrons about the proton itself generates a field in such a way that at the proton, it opposes the applied field. Instrumentation. NMR instrumentation consists of several components. Let's discuss them in briefly. Sample holder. It is the glass tube with 8.5 cm long and 0.3 cm in diameter. Permanent magnet. It is used to provide homogeneous magnetic field at 60 to 100 MHz. Magnetic coils. These coils induce magnetic field when current flows through them. Sweep generator is used to produce the equal amount of magnetic field pass through the sample, which is not shown in this figure. Radio frequency transmitter and radio frequency receiver both are used in NMR instrumentation. A radio transmitter coil is used to produces a short powerful pulse of radio waves. A radio receiver coil that detects radio frequencies emitted as nuclei relaxes to a lower energy level. And for readout systems, computer is used for the data analyses and to record the data. And printer is used to print the collected information. These are the components used in NMR instrumentation. We can see the general sketch of NMR instrumentation in the figure also. The information obtained from NMR spectra is chemical shift. It gives the information about the composition of atomic groups within the molecule. Spin-spin coupling constant. It gives the information about adjacent atoms. Relaxation time. It gives the information on molecular dynamics. Signal intensity. It gives the quantitative information, for example atomic ratios within a molecule that can be helpful in determining the molecular structure, and proportions of different compounds in a mixture. The applications of nuclear magnetic resonance are: they are used in analysis of molecular structure and identification of unknown chemical substance. They are used in quantitative analysis of mixtures. They are used to know the speed of chemical reaction, identification and detection of binding site and interaction. They are used in research for determining the content and purity of a sample. They are used to know molecular mobility and interatomic distance. They are used to study drug metabolism. They are used in 3D structure determination of proteins and nucleic acids. And they are used to know molecular weight, conformation of polymer in organic and polymer chemistry, etc. The advantages of nuclear magnetic resonance are: the sample measurements are non-destructive and there is less sample preparation required in NMR techniques. We can calculate 3D structures using suitable computer. This method is capable to guide us for the observation of the chemical kinetics. This method can be used in molecular modeling procedures. And in this method, we can investigate the influences of the dielectric constant, the polarity and any other properties of the solvent, etc. The disadvantages of nuclear magnetic resonance are: this method is quite difficult to study very high molecular masses complexes. The resolving power of this method is less than some other type of experiments. The cost of the experimental implementation is increasing with the higher strength and the complexity of the determination. This method is not suitable for all samples. This method cannot be used with amyloid fibrils. And it requires high concentrations of soluble protein, etc.